Venturing into space is challenging. It's like riding a unicycle uphill with a bag full of explosives. It's slow, limited in carrying capacity, and can be deadly. Rockets need to reach speeds of around 40,000 kilometers per hour to escape Earth's gravity. To achieve such speeds, rockets primarily consist of fuel containers with minimal payload. This is not ideal for interplanetary travel, where survival and potential return require carrying a significant amount of supplies. So, is there a way to reach space with less fuel and more cargo? The answer lies in infrastructure, a solution that has greatly improved transportation on Earth, whether it's roads for cars, ports for ships, or railways for trains. We can apply a similar concept to space travel. Space infrastructure would make it easier and more cost-effective to travel to orbit, the Moon, Mars, and beyond. But what exactly is space infrastructure? Unlike a hypothetical space elevator, which currently remains a concept, there is a simple yet promising technology that doesn't require new science, magical materials, or significant investments. This technology has already been successfully tested in orbit. It involves a cable and a weight known as a tether. The concept is surprisingly straightforward. What if we placed these tethers, hundreds or thousands of kilometers long, in space and had spacecraft use them as a ladder to climb to higher altitudes and gain speed? This concept is known as the Skyhook. It works even better when it's rotating. A counterweight keeps the tether in place as it spins in a circular motion. The rotating tether slows down at the bottom and speeds up at the top, similar to a catapult. This means we can transfer energy from the tether and gain a massive boost when it is released, essentially doubling the rotational speed. Specialized fibers exist that can withstand the extraordinary stress the Skyhook would face. To protect our tether from collisions with rocks and meteors, we can wrap it in a network of fibers. Since our Skyhook would pass through the same spot multiple times a day, it would enable reusable rockets to reach it. Of course, it's not that easy. At its lowest point, the tether would travel toward the atmosphere at a speed of 12,000 kilometers per hour. Due to Earth's atmosphere, we can't lower the Skyhook too much, as it would heat up from friction with the air. Therefore, it would submerge at an altitude of 80 to 150 kilometers, not lower. To achieve this, we need a space vehicle capable of reaching the tether. Although this is no easy task, it is still much cheaper than launching a rocket filled with rocket fuel to achieve speeds of 40,000 kilometers per hour. Capturing the tip of the tether is also a challenge. We have only a short time of 60 to 90 seconds to locate a small moving object in the sky traveling at Mach 12. To make this easier, the tip could have a long fishing hook-like device with a navigation drone that helps the spacecraft make the connection. Another challenge is maintaining our Skyhook in orbit. The more spacecraft that attach to it and pull themselves up, the more they utilize the momentum that keeps it stationary. If we do nothing, it will slow down and eventually fall into the atmosphere. Here, we can deceive the universe a bit. The Skyhook becomes an orbital energy battery. It allows for balanced round-trip exchanges. Incoming spacecraft bringing people and materials to Earth would add energy to the tether, which can be transferred to other spacecraft departing for space. In this way, the tether doesn't lose energy. The more we use it, the more cost-effective it becomes. If energy depletes with each use, we would need to replenish it periodically. This can be achieved through various means, such as deploying solar panels along the tether to generate electricity or utilizing onboard propulsion systems to provide additional energy. By carefully managing the energy balance, we can ensure the long-term stability and functionality of the Skyhook. The benefits of a Skyhook system are numerous. First and foremost, it drastically reduces the amount of fuel needed for space travel. Instead of relying solely on rocket propulsion, spacecraft can utilize the rotational energy of the tether to gain speed and reach higher altitudes. This opens up new possibilities for larger payloads, longer missions, and more efficient interplanetary travel. Additionally, the Skyhook enables reusable space vehicles. By providing a fixed point in space for spacecraft to dock and refuel, we eliminate the need for expensive and resource-intensive rocket launches. Reusable vehicles can make multiple trips between Earth and space, significantly reducing the cost and environmental impact of space travel. Furthermore, the Skyhook can serve as a crucial stepping stone for future space exploration. With easier access to orbit and beyond, it becomes feasible to establish permanent bases on the Moon, Mars, and other celestial bodies. The infrastructure provided by the Skyhook can support the construction of larger spacecraft, facilitate resource extraction, and enable the development of sustained human presence in space. However, it's important to note that the concept of the Skyhook is still in the realm of theoretical exploration. While there have been successful experiments with tether technology in space, implementing a fully functional and operational Skyhook system would require significant technological advancements, engineering expertise, and financial investments. Nevertheless, the potential benefits of such a system make it an intriguing concept worth further investigation and research. As our understanding of space travel advances and our capabilities continue to grow, the realization of a Skyhook infrastructure could revolutionize the way we explore and utilize space, opening up a new era of possibilities for humanity's future in the cosmos. In addition to the benefits I mentioned earlier, the Skyhook system could also enable new scientific endeavors and advancements. With increased accessibility to space, scientists and researchers would have greater opportunities to conduct experiments, gather data, and make discoveries that can further our understanding of the universe. It could lead to breakthroughs in astronomy, astrophysics, planetary science, and even fields such as medicine and materials science that can benefit from the unique environment of space. Moreover, the Skyhook could facilitate the growth of commercial space activities. By reducing the cost and complexity of reaching orbit, it would attract more private companies and entrepreneurs to invest in space-based ventures. This could include satellite deployment, space tourism, manufacturing and microgravity, and other innovative industries that can drive economic growth and technological innovation. Another advantage of the Skyhook is its potential for space debris removal. As the number of satellites and other objects in orbit continues to increase, the issue of space debris poses a significant risk to future space missions. The Skyhook could be used as a means to capture and deorbit space debris, reducing the clutter and improving the safety of orbital operations. However, there are also challenges and risks associated with the Skyhook concept. One major challenge is the engineering and construction of a robust and durable tether system that can withstand the harsh conditions of space, including micrometeoroid impacts, radiation, and extreme temperatures. Ensuring the stability and reliability of the tether over long periods of time would require advanced materials and structural designs. Another challenge is managing the dynamics of the system. The rotational motion of the tether and the docking of spacecraft would require precise control and coordination to prevent collisions and maintain stability. This would involve sophisticated guidance, navigation, and control systems to ensure the safety of the spacecraft and the Skyhook structure itself. Furthermore, there are legal and regulatory aspects to consider. The establishment of a Skyhook system would require international cooperation and agreement on issues such as orbital rights, space traffic management, and liability for potential accidents or damages. Developing a framework that enables the operation of a Skyhook system while ensuring the responsible and sustainable use of space resources would be essential. In conclusion, the concept of a Skyhook system holds great promise for revolutionizing space travel, exploration, and commercial activities. It offers the potential for reduced costs, increased accessibility, and expanded capabilities in space missions. However, realizing this concept would require significant advancements in technology, engineering, and international collaboration. As we continue to push the boundaries of space exploration, the development of a functional Skyhook system could be a game changer that propels us further into the cosmos.